This video is on higher order derivatives. So just as you can take the derivative of a given function, you can take and the derivative is a function itself, then you can take the derivative of that. So we had something like y equals 3x to the fourth plus 2x squared. Y prime is its derivative, which we know is 12x to the third plus 4x. And you can see that the derivative is itself a function. Then we can take the derivative of that, and we call that the second derivative. In this case, it would be 36x squared plus 4. And so on and so on. If we wanted to take the derivative of that, because that itself is a function, we could say the third derivative, represented as y triple prime, is 72x. And of course, we could do y, and we call it fourth derivative, is 72. And we could take the fifth derivative, and that would give us 0. That's as far as we can go with that particular function. If it were a higher degree to begin with, we could have gone further out. So this is the notation for higher order derivatives. Or, of course, you could use f of x instead. So I'll do that, and I'll show you what happens with a trig function. So let's say we had sine of x. We'd say f prime, its derivative, is the cosine of x. F double prime, second derivative, is the derivative of the cosine is negative sine x. The third derivative, f triple prime, is the derivative of the sine of x is the cosine of x, so negative sine x is negative cosine x. And f, fourth derivative, f of x, derivative of the cosine is negative sine, and it's already negative, so it's a negative of a negative, so it's the sine x, and we're right back where we started again. So the fourth derivative is the same as the original function in this case. Okay, so that's two examples. One a polynomial function, one a trig function. I also wanted to show you the different notations and how they're written. And let's talk for a minute specifically about the second derivative. Second derivative, if you've taken physics, is acceleration. So we call this the rate of change of the rate of change. Rate of change of the rate of change, or the rate of change of the velocity. So the derivative is the velocity. The second derivative is acceleration, or the rate of change of the velocity. Okay, so that's just an application, one particular application, and I just want to show you a couple of graphs and some interpretation of what it means, what the second derivative means. So if you had a graph that looks like this versus this, and this. Let me make sure you're still seeing this in the video. Okay. In the first two examples, the slopes are positive. And when you say slope, you're saying that the derivative. So if these represent f of x, f prime of x, meaning its derivative, in this case, the slope everywhere is positive because this thing is increasing. So the derivative is positive. Let's do each of these first. So f prime of x is also positive here because this is increasing. It has a positive slope. F prime of x is negative on this one because it's decreasing. And f prime of x is negative on this one because it's decreasing. When you talk about the second derivative, you're talking about the rate of change of the rate of change. So you're saying, okay, this thing is increasing, but what is happening at the slope at each point? So here's a slope, here's a slope, here's a slope. You can see that it's getting steeper, or that the slope is increasing. That's what the second derivative tells us. It's not just that it has a positive slope, but that it's increasing. So it's the rate of change of the rate of change. In this case, the slope is increasing. In this case, even though this is an increasing function, you can see that the slope is decreasing each time, and it's flattening out at the top. So second derivative is, this is f double prime, is negative. So this function is increasing at a decreasing rate. This function is increasing at an increasing rate. Okay, so in terms of something to make it more relevant, talking about COVID, if you had this graph of the population people getting COVID, this is, obviously we don't want it to be increasing, but we definitely don't want it to be increasing at an increasing rate. We'd rather see it increasing at a decreasing rate, meaning it's falling off or slowing down in this case. Okay, here it's speeding up. And I think you talk about that in physics as well. When the signs are the same, well, you don't refer to it as derivatives, but when the signs are the same, the object or whatever is happening there is speeding up, and when they're different signs for the first and second derivative, it's slowing down. Okay, same thing here. This is a negative, but the second derivative, it shows us that we have a slope here, and then it's more negative and more negative, so it's increasing. And in this case, the slope is negative and it's decreasing. So the second derivative, f double prime, is negative. Okay, so it's decreasing at a decreasing rate. This one's decreasing at an increasing rate. And that's the second derivative. Calculating the derivative, as I said earlier, is very easy to do. It's just second derivative. It's just a derivative of the derivative. But this is more of an interpretation of what it means. Okay, that's higher order derivatives.